Hello friends, I hope you're doing well. I've created this video to get more knowledge about how to size the servo wall or proportional wall and how to calculate the error in feedback signal. So let's begin and the same this is the spreadsheet. As always, you can download the spreadsheet from description area of this video on YouTube, or you can send me email. I will send you the spreadsheet if you cannot find the link. So as always, yellow shell CAE is the input value for this calculation, and gray area where you can find your output. I'll explain all the details how it works and what is the output of this calculation. So let's say you have pretty good knowledge about your application. You have your cylinder and some basic dimension details. Then this spreadsheet will help you to get how much flow your proportional wall need to perform accurately, and what is the voltage error value, and if it's milliamps, then what is the milliamps value you need to get, or you can basically analyze what you are doing, and you can get the pressure ratings as well, like what is the pressure drop in servo wall or in your application and how much you need to consider. And based on this value, you can go to any OEM, you can open the data sheet of servo wall or proportional wall, and then you can select correct size. So let's begin and let's see some example over here. So this is for balanced cylinder. You can do it for unbalanced cylinder. Let's say it's double acting but a single side rod. I have taken this example for double side rod. So you can change the values over here, and you can basically easily change it from balanced cylinder, or I can upload same spreadsheet for unbalanced cylinder as well. So keep watching and subscribe my YouTube channel for upcoming videos, and let's begin. So let's say load on the cylinder. Again, it's a vertical load I'm considering. So I'm considering 2,000 pound load on the cylinder, and it's only on one side. So the load will be over here, and then there is something more load over this area. Then we have to do the same calculation, and we have to check the worst case. So I'm taking the 2,000 pound over here, and let's say the bore size of cylinder is 4 inch and rod size is 2 inch, and the stroke will be, let's say, 10 inch. So, and the time of extension is 3 seconds. I have considered 3 seconds. You can change it as you need and what your application demands. And the tube size, it's basically hose diameter. So well, it's always recommended that you should put servo or proportional wall to near to your actuator, so uh, it will be easy to tune it, and it will be easy to get feedback quickly, and that's what it's recommended. So let's say your actuator having the servo wall mounted itself on it, and if it's not, then it should be near somewhere. And the hose size or tubing size from servo wall to actuator, you have to consider, or if you know, then you can enter it, or maybe you can calculate it by a different calculation I'm going to upload in future. You can check it, but I'm assuming here it's 0.5 inch, and the length of tubing, let's say it's 10 inch. So the length will be from this point to this point. It's only a single side length I have mentioned over here as well. So length of tube each side, so from here to here it's 10 inch. If from here to here it's like something different, then you have to consider the worst case as I mentioned, but I'm assuming 10 inch here. So it will give you some basic details about bore area, roadside area, annulus area, gravity force, and tubing area. I'm going to some rate cells over here. So these are some critical values you have to consider for your selection of servo valve. So Vn is it's basically difference in volume, or maybe it's annulus area side volume, and Vn plus VLP, it's total volume from of annulus of cylinder plus tube. So I can easily calculate the mass, and I have considered 2.5 kilopas or kilo psi or mega psi. You can say like 2.5 multiply 10 raised to 5 psi bulk modulus, where you can change it. In general, the oil hydraulic oil bulk modulus is somewhere between 2.5 to 3, but you can change it as you need or as your application demands. And W is the natural frequency. So natural frequency, you can calculate it by entering these parameters, and this will definitely help. I'm not going to explain natural frequency and how it works here, because it will definitely go to the new topic, and maybe I'm out of topic then. So this is a natural frequency in radian per second, and some factors we need to consider. I mentioned some applications here for boom lifting application and other critical applications of crane. It is very important to increase the natural frequency of system to avoid accidents. So I'm considering more factors, and I'm trying to reduce and going and make it like what will be the minimum natural frequency of this system, so I can avoid the resonance, and we can use the system easily, and it will work in field smoothly. So these are some W usable that will use in the calculation. It's some factors I'm considering for further calculation, and of course W critical. It's again, it's always like natural frequency divided by 3 will give you W usable, and again divide by 3 gives you W critical. And from there I can calculate the time factor. So if I'm checking this time factor is it's mainly gives you like how much time spool will take to close from its actual position to the traveling end position. So again, it's a theory, and I have to consider some factors here. So 60, it's a universal factor, and this gives you some time. And for getting these details, you don't need to do any further calculation. Just enter your details on yellow cells, and you will get this information. For getting theory of this calculation, I'll upload the PDF of theory calculation, some pages, so you can read it, and you can easily get these factors and what each parameter says. Okay, so let's move ahead, and let's get the value of V maximum. So V maximum is the maximum velocity of piston required. So this is the velocity of piston that we need to consider for any other calculations. If you are considering servo valve in your application, so this will be your uh, cylinder velocity, or you can say piston velocity for your actuator. And the flow, once you get the velocity, you can easily get the flow. So Q is the oil flow required to achieve Vmax, and it's 8.552 GPM. Because this is like I've considered 10 each stroke, that's why it's a high flow coming up. The same value in cubic inch per second, it's 32.81 somewhere. And as we have uh, if you know like Newton's second law, it's F is equal to ma, so can easily get the acceleration value, and it's 26.96. It doesn't matter, I know, just mentioned, but we need this value to get force required to accelerate the piston. So this is the force value, and this much amount of force we need to accelerate the piston to avoid this. It's not avoiding, but just to move the piston or actuator. And we have to consider a lot of other forces to move the piston. Let's say it's not only load, it's load plus force required to accelerate. It's like friction force and seal friction as well. So if I'm considering all the three forces and doing summation, then this will be the force value. So it's like 2339.7 pound. And if you remember what's the what was the original load was like 2000 pound, but now I'm getting the exact value, like how much load actually on the piston to move. So this will be the load size and pressure required to move this much load. So it will be like 250 psi somewhere. Okay, so these are not the exact value like on which we need to design our system. These are some internal calculation, but I have to consider other fractions and other losses. So let's see what are the losses. Loss of pressure in servo valve. It will be again a calculation. You can check the equation, but this will be the loss in servo valve. It's like 82.79 psi, and I'm assuming rated pressure of servo valve is 3000 psi. So the pressure should be at pump with it's like pressure required plus loss, so it will be like 372 psi somewhere, and the q rated or q rated, if you know the general equation, it's like q actual is equal to q rated under root PV by PA, or you can do that calculation and you can easily get q rated. So this is the value, this is the flow that we need to supply to our servo valve to get all the values correct, and can easily move the cylinder, and you can do whatever you need. So this is the flow value, and we have to consider this flow to get this much amount of or this much like this is the flow where you need to uh, go to a data sheet of any OEM, and you can select your servo valve based on this and above pressure loss equations. Uh, as I mentioned, this Excel sheet as well give you some feedback gain and voltage and some other values as well, like what is the error voltage signal. So you can get these details. Just need to enter what is the maximum input current. So let's say I just make the values enlarged and visible in this calculation. So I just made it like 100 milliamps, but you can change it. It's plus or minus 10 milliamps, so you can do it like plus 10, and you can get the gain value and feedback signal loss and all the other details. I'm not explaining all things in detail, otherwise it will be like a big and huge video, but and it will lost me and you somewhere. So it's just conclude it, and if you need more details about anything or you did not get anything on this calculation, then please DM me on YouTube comment section, and you can send me email as well. I hope you enjoyed, and I hope you get some knowledge about this. If you have again any question, then yes, comment on YouTube. Please subscribe and get more cool information about hydraulics. Hope you're safe in this COVID-19 situation, and take care, stay safe. Bye.